So before we go into something called reducing fractions into their mixed radical form, I gotta show you prime factorization. I know there's something that you dealt with all the way back in grade 7, but I want to look at the prime factorization for a second. I want to look at this. This is the process of writing a number as a product of prime numbers. And you remember what a prime number is. A prime number is only divisible by 1 and itself. So look at something like 24. We're going to break this down using what we call a factor tree. Okay, so if you break 24 down into 2 factors, one of the cool things is you know that being that this is 4, it's divisible by 2. So 2 times 12, of course, gives us 24. But if we keep breaking this down, we know that 12 is 4 times 3 or 6 times 2. It all works out to be the same thing in the end because they're all going to be our nice little prime numbers. So that's the way we represent 24. And knowing how to do this really helps when it gets to simplifying radicals. So that's why I want to spend this podcast doing this over and over again until you really get it. Look at 125. Number ends in 5. So you know and I know that that's going to be divisible by 5. Okay? So what times 5 gives us 125? Well, 25 does. And check this out. Look how this factor tree just keeps on going. 5 times 5. So that becomes very important when we get into radical forms. Look at 196. Now, in terms of 196, here's the thing that bothers me, is a lot of people see a number like this, which is a bigger number, and they start dividing it by 2. Oh, well, you know, great. That's going to make this factor tree 1.5 miles long. So here's what I want you to do. I want you to take your calculator first, and I want to see if you can pick a number that'll divide into 196 that's bigger than 2. That's really hard to do at first. But you know what? Try something bigger. Try 4. See if 4 will go into it. It does. And look how pretty this is, because what happens is I recognize 49 here as a perfect square. So check this out. This is 4 times 49. Now, the cool thing about this is that the 4, you know, breaks down to 2 times 2, and the 49 breaks down to 7 times 7. Look how pretty and easy and just beautiful that is. It sure beats dividing it by 2. So try to find bigger numbers other than 2 that I can divide into. Case in point, look at this one. Could you imagine how big the factor tree would be for that particular one? Oh, it would drive me absolutely crazy. So let's go into here. Here we go. Let's clear this, right? There we go. Clear that and clear that. And let's put in 4096, 4096. And let's start thinking, let's start big numbers. Let's start thinking bigger numbers. Not just 4, not just whatever. Let's go up. Let's try maybe dividing it by something like 16, and let's see what we get. Still too big. Still too big. Let's try 4096. Let's divide it by, let's try double of 16. Let's try 32. See if that works in. Now we're talking. Now we're getting into some pretty numbers. Let's even go one more. Let's go 4096. Let's double the 32. Let's try 64 and see if that works out. Oh my goodness, it's 64 and 64. You know and I know now that 4096 is actually a perfect square, which is 64 times 64. And you know that 64 can also be broken down because you know that 64 can be, guess what? Square rooted into 8 and 8. So check this out. You can break this guy now down into 8 and 8. And look at this. Look how much nicer this factor tree is. If we went by 2s, we'd be here until Christmas. Okay, so let's keep on going. 8 is just 2 times 2 times 2. This 8 is 2 times 2 times 2. This 8 is 2 times 2 times 2. And this final 8 is 2 times 2 times 2. Which is really interesting because now you can take one extra step, which I think is really cool. And watch this. Count up the number of 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 496 could actually be written as 2 to the power of 12. Isn't that cool? So this is just such a nice way of doing things. Don't always rely on going to something as silly as this because you're going to be there all day. Try different numbers, try bigger numbers, see if they actually divide in. That's going to save you a lot of time.